right, let's dive in. We're going to try and decode something that's, well, one of the most revolutionary forces of our time, data science. You can think of it like this hidden language that helps us find meaning in all the digital noise that's all around us every single day.
And when I say noise, I mean overwhelming is probably an understatement. We're generating an absolute tidal wave of data. And the crazy part is it's invisibly shaping pretty much everything we do, from a simple Google search to the news that pops up in your feed.
I mean, the sheer scale of it is just staggering. Globally, we produce 2.5 quintillion bytes of data. And that's not per year or per month, that's every single day. It's a number so big it's hard to even picture, right? To put that into perspective, if each byte were a gallon of water, that would be enough to fill the entire Amazon River twice. And get this, that number is only accelerating. So you've got to wonder, where is all this data storm coming from? Well, the biggest source? It's us, you, me, everyone. It's our smart TVs, our cars, our social media feeds, every single movie we stream, every Google search we make. It's all just another drop in this massive digital ocean. Okay, so we have all this raw information, right? We'd be completely lost, just drowning in it if we couldn't make sense of it. And that's where the search for insights really begins. The big question is, how do we turn all that noise into something actually useful? And the answer to that question? It's data science. I like to think of it as part art, part science. It's kind of like being a digital detective. You're sifting through these mountains of raw data, looking for clues, these hidden patterns and insights that can help solve some really complex, real-world problems. And, at the end of the day, that's the core goal, especially for businesses. It's all about finding those hidden gems of insight that let you make smarter decisions. It's really about turning all that raw data into actual decisive action. Let me give you a classic real-world example of this in action. A while back, data scientists at Walmart asked what seemed like a simple but really powerful question. What are people actually buying right before a hurricane is about to hit? And the answer they found was probably not what you'd expect. It wasn't just batteries or bottled water. The top-selling item? Strawberry Pop-Tarts. No, seriously. And that's exactly the kind of weird, non-obvious, but incredibly valuable pattern that data science is so good at uncovering. And we're not talking about a small blip here. The data showed that sales of Strawberry Pop-Tarts literally increased by 7 times, 7-fold, right before a hurricane. So with that one little insight, Walmart knew exactly what to do. They started stocking their shelves with Pop-Tarts right next to the flashlights. They turned a surprising pattern into a seriously brilliant business move. And once you start looking for it, you realize this stuff is everywhere. Netflix isn't just guessing what show you might want to watch next. It's analyzing everything you've ever watched. When Facebook suggests who to tag in a photo, yep, that's data science. And that famous customers who bought this also bought section on Amazon, that's pure data science at work, personalizing your world. Okay, so we've talked about the what and the why. Now let's pull back the curtain a little bit and look at the how. Let's walk through a simplified version of how data science actually works. So it usually follows a basic 4-step process. Step 1 is data exploration. This is where the scientists are basically detectives, just digging in and getting a feel for the data. Then comes what's often the hardest part, data wrangling. This is the, let's just say, time-consuming process of cleaning up messy, inconsistent data. It has to be done. Only then can they get to the fun part, data modeling, where they actually build the predictive models to find a solution. And last but not least, evaluation. They've got to test the model to see how efficient and accurate it really is. So what's the engine that's powering all of this today? Well, it's machine learning. This is the real magic. It's what allows computers to learn directly from data, without a human having to explicitly program them for every single little task. It's what makes these models so smart. Now, machine learning basically comes in 2 main flavors. First up, you have supervised learning. The best way to think about this is like a student who's learning with a teacher and an answer key. The data is already labeled, so think of an inbox full of emails that are already marked spam or not spam. The model just learns to tell the difference. Then you have unsupervised learning. This is more like a detective showing up to a crime scene with 0 clues. The data isn't labeled, so the model's job is to find hidden patterns or groups all on its own. A good example is how a music app might group listeners with similar tastes, without ever being told what a genre is. So all of this work, the data cleaning, the modeling, the machine learning, it's all building up to one thing. It's building towards the most powerful and impactful part of data science, the power of prediction. This is really where data science starts to feel like a superpower. It lets us move from just looking at what happened in the past to making these really powerful, educated guesses about what's going to happen in the future. It's the huge difference between being reactive and being proactive.
And this predictive power, it's a total game changer. With it, businesses can start to anticipate what you need, sometimes even before you know you need it. Companies can forecast sales trends or even identify financial fraud before it does any damage. It's fundamentally shaping the technology and the products we use every single day.
So when you boil it all down, we've built these incredible tools that let us ask our data pretty much anything we can think of. But the real question, the one that's going to define our future, isn't what we can ask. It's what should we ask next?